All right, folks, it's Bass Action back in action here. In this video, we're going to look at truth tables, and don't worry if by the end of the video, if you're not totally comfortable with how we're going to use them, just as long as you can kind of follow where the true and the falses are coming from, that's good enough for us. Okay, you should be on the back of your yellow foldable. We're going to be on the left-hand side. The first thing we want to look at is a couple vocabulary words. We're going to start with the word negation. All right, negation simply means the opposite meaning or truth value of some statement. So let's say that I have a statement, I'm going to call it statement P, and my statement is, it is September. It is possible that my statement P could be true. It's also possible that my statement P is false. So the negation of that statement will just change those truth values. So if statement P was true, the negation of it then would be false, and if statement P was false, the negation of it would be true. We're also going to learn how to write these symbolically. So instead of just being able to say, oh, if it's true, it's false, if it's false, it's true, we want to know what this would look like symbolically. So the negation symbol is that little tilde that we use for our congruence, and then we would say P. So that's what it would look like symbolically to say the negation of statement P. The next two words we're going to look at are going to be conjunction and disjunction. Now, up until now, conjunction, it would, in your mind, probably have covered both of these words. But for our purposes mathematically, conjunction is only going to mean the word and conjunction or disjunction is only going to mean the word or. We're also going to have some symbolic notation for conjunction and disjunction. So a sample sentence with a conjunction would say, I want a cookie and Starbucks. The word and symbolically can be written as an upside down V. And conjunctions will only be true when both parts are true. So in order for you to make the conclusion about the truthfulness of a statement with a conjunction, both parts of that statement must be true. A disjunction, however, has the word or in it, so that would be, I want a cookie or Starbucks, and an or statement, an or symbol, is going to just look like a V. Disjunctions are true when either part is true. It doesn't matter. We're going to take this idea and we're going to put it into what's called a truth table. Truth tables are going to help us do some analysis later. So since I'm looking at conjunctions and disjunctions, that would mean that I have two pieces that I want to consider, a P and a Q part. Now, when we put this into the table, we want to look at all the possible combinations of true and falses. So the first column for our first statement, we always fill it out as a true, true, false, false. Then the second column becomes a true, false, true, false. This allows us to match up all the potential combinations of trues and falses. So if I'm looking at the conjunction of P and Q, we would write that as P and, remember that's the upside down V, Q. And in order for this statement, P and Q, to be true, both parts, P and Q, have to be true. So the only part in this truth table where I see both lines are true is this very top line. So that's the only way this statement can be true. All the other parts of the statement have to be false, because if either of these end up false, there's no way this could be true. The disjunction, however, says P, and then I'm going to use my V for or, Q, says that as long as I can find a true somewhere here, I'm happy. So the statement itself is true. So this would be true, this would be true, this would be true, but the last statement would have to be false. The last thing that we're going to do then is we're going to look at how this can be applied. So let's say I have a statement, I'm going to call it A, and its rectangles have 4 right angles. Well, that statement is clearly true. And let's say I have a statement B, squares have 6 congruent sides. Well, that statement's clearly false. So if I want to do an analysis taking all this symbolic notation and put it together, I can do that. the negation of A, since A is true, the negation of A is false. The V means or. B, we already identified, is false, so I can fill that in. And from the truth table up above, I can see that a false or a false means that the overall statement is false. And I can see that right here. If I go ahead and I grab the truth value of A and I put it here, upside down V means and. The negation of B would be true. True and true, we can see from the truth table up above, means that the overall statement is true. Now, the last thing that we're going to do is we're going to look at what do we do when we don't know all the parts. So I'm going to give you a couple parts. I'm going to tell you that Q and R are true, and then we're going to substitute in. We're going to use this statement right here. So I don't tell you anything about P, so I leave it as negation P. The V means or. Q, it told me, is true. Upside down V means and R I told you is true. Now, if the V means or and this one is true, this entire statement here is true. So now this becomes true, and from up above, we can conclude true. On our next one, I'm going to tell you P and Q are true. So now I have a true, and I have a true, and I don't know anything about or the R. So let's look inside. I know this is true. I know this means and. The only way I can make a conclusion about this part is if I know something about both of these. If I don't know something about both, I can't make a conclusion about any, so I say can't determine. I can't move on from here. Okay, and then in the next video, we'll look at the Venn diagrams, and then we'll practice more in class.